So let's do problem number 4 of exercise 3.3 linear equations in two variables chapter. Here we have two equations here and we are going to derive the value of x and get the value of x and y from these two linear equations. Okay, see, this is equation 1 and equation 2. Since these two equations are decimal numbers, what we are going to do is we are going to multiply these two equations by 10 so that we can get rid of this decimal point. So 0.2 into 10 is, it shifts to the next place, it is 2x. Plus 3y is equal to 1.3 into 10 is 13, isn't it? So 4x plus 5y is equal to 23. So we have got these two equations here, and what we are going to do is we are going to express x in terms of y. So for this, you can take both either of these two equations. I've chosen the first equation here. So 2x is equal to 13 minus 3y. This 3y, when you transpose this to the other side, you get as negative 3y, and x is equal to 13 minus 3y by 2, isn't it? Now we've got the value of x here. We are going to substitute this value in this equation. So in the place of x, what I'm going to do is, in the place of x, I'm going to substitute this value, 13 minus 3y by 2. So we know that 2 is a factor of 4. Hence 2 into 2 is 4 here. So what you get here is 2 into 13 minus 3y plus 5y is equal to 23. When you multiply this by 2, 26 minus 6y plus 5y is equal to 23. And what is negative 6y and positive 5y? It is negative 1y, isn't it? So 26 minus y is equal to 23, and negative y is equal to 23 minus 26, and you get it as negative 3. So negative y is equal to negative 3 means y is equal to 3. So you got the value of y here. Now we are going to get the value of x by substituting this value of y in either of these two equations. So I have taken both the equations and I've taken x, the value of y here as 3, and I have substituted the place of y here, that is 2x plus 3y is equal to 13. That means 2x plus 3 into 3, this is 9. 2x plus 9 is equal to 13, and x is equal to here 2. And for your information, I have substituted this value in both the equations, and you can see that we get the same value of x even if you substitute in second equation. Okay, so no need to do both. No need to substitute this value in both the equations. Just for your information, so you get the value of x as 2 here, and value of y is equal to 3 here. Fifth problem of exercise 3.3. What's the question here? Root 2x plus root 3y is equal to 0, and root 3x minus root y is equal to 0. So from this first equation, I'm going to get the value of x here. I'm going to express x in terms of y. So when you transpose this root 3y to the other side, what you get here is 0 minus root 3y, and x is equal to 0 minus root 3 is minus root 3, and minus root 3y by root 2. This root 2 when it comes to the other side by root 2. So let me substitute this value of x in the second equation. From this first equation, I got the value of x here, and I'm going to substitute this value in the second equation. That is root 3 into x minus root 8y is equal to 0. So in the place of x, I'm going to substitute root 3y by root 2. What happens when root 3 and when you multiply root 3 and root 3? Get it as 3, isn't it? Root 3 into root 3 is 3. So negative 3 by root 2y minus root 8y. So what we are going to next do is, we are going to take the LCM of 1 and root 2. It is root 2 itself, and by cross multiplication method of LCM, it is 1 into root minus 3 is minus 3y, and minus root 8 into root 2. What is root 8 and root 2? It is root 16, isn't it? Otherwise, you can do by this method also. You can take root 8 as 2 root 2, and 2 root 2 into root 2 is 2 into 2, 4. Or root 2 into root 8 is root 16. So root 16y. What is root 16? It is 4. So my root 16 is 4. So negative 3y minus 4y is by root 2 is equal to 0. When you take this root to the other side, it becomes 0 into root 2. That is, whole value becomes 0 here. So negative 7y is equal to 0, and y is equal to 0 by negative 7, and it is 0 itself. So we got the value of y as 0 here. Let's substitute this value in any of these equations. Two equations here. We've got two equations. I'm going to substitute the value of y as 0 in this first equation, and what you get here is, so in the place of y, I have substituted 0 here, and root 2x plus root 3 into 0 is 0. Isn't it? So root 2x is equal to 0, and x is equal to 0 by root 2, it is 0 itself. So we got the value of x and y as 0 here.